Let's discuss solve problem 6 on singly linked list. Consider the function f defined below. This is the function f defined. For a given linked list P, the function f returns 1 if and only if not all elements in the list have the same data value. The elements in the list are sorted in non-decreasing order of data value. The elements in the list are sorted in non-increasing order of data value or none of them. This question has been asked in GATE CS 2003. I would encourage you to pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. You can see over here struct item has been declared, which is nothing but a node. This consists of two parts. One is data part and the other one is next part. It simply indicates a node. A node consists of data as well as link to the next node. Now let's move to this particular function. Here this function receives a pointer, and according to the question, this pointer is the pointer to some singly linked list. Let us suppose this is the singly linked list and these are the data values available in this singly linked list: 23, 24, 25 and 26. P is the pointer pointing to the first node of the list. Now, inside this function we have a return statement, and within this return statement we have all these lines of code. Our job is to understand all these lines of code and identify when this function will return 1. Now let's just evaluate these lines of code one by one. The first line of code is very simple. Here we're checking is P is equal to null. That means we are checking is linked list empty, right? That's what we are checking, right? And the second line of code is also very simple. Here we are checking P next equal to null, which means we are checking is there only one node in the linked list? We know that P is not equal to null and P next is also not equal to null. So these two conditions are not satisfied, which means we can simply replace this and this by false. False or false is actually false. But let's just wait. We have one more line of code. And this will decide whether 1 will be returned or 0 will be returned from this function. Okay? Now here comes this third line of code. P data less than or equal to P next data. This is the first part, and FP next. Now this is interesting, let me tell you. If this is the only line of code we have, then it is easy to find out the answer for this particular question. But we are also calling the f function here. Now this makes this code a little bit complicated, right? Because recursive procedure is involved here. Here we are calling this function f inside this function f. This is a recursive procedure, right? Is P data less than or equal to P next data? Let's just identify. We know that 23 is less than 24, right? That means P data is less than P next data. So it is clear that we can replace this line of code by true. This condition is satisfied, right? Now we can write this whole line of code as true and F2000. We can replace this P next by 2000 because we know that P next is actually 2000. That's why I've written these addresses over here. And you can take any address, that doesn't matter. So here we can write 2000. Actually we are calling f function again, and here to this pointer we are passing 2000. And let me tell you, this pointer is local to the next function call. So it is clear that a new pointer is created, that is P pointer, which will hold this address 2000. Now we know again P is not equal to null, P next is not equal to null. Again we will evaluate this line of code. Here in this case we can see that P data is actually less than P next data. Again we can replace this line of code by true. So we can write true and with F3000. This time 3000 is passed to the f function, isn't that so? Because this is P next. And what is P next? P next is 3000. So again this pointer, that is new pointer, is now holding this address 3000. And let me tell you, this is a new pointer declared. Okay, this is not the pointer which is similar to the previous function calls. For every function call, a new pointer is created. Now within this function, we will again evaluate all these steps. We know that P is not equal to null, P next is not equal to null. Again, we will evaluate this line of code. We will check is P data less than or equal to P next data. We can see over here that P data is actually less than P next data. So again, this line of code will be replaced by true. And P next will get replaced by 4000. So it is clear that this line of code can be replaced by true and F4000. Now to this function, we are passing 4000, which is received by P. So here again, a P pointer is declared, which receives this address 4000. Now in this case, you can clearly see P next is null. So this line of code will get evaluated and we can simply replace this by true. We know that true or with anything is true. So no matter what, true will be returned back. And returning back means that this F4000 can be replaced by true. As simple as that, because we are returning back, right? And where it is returned? To the caller. And caller is actually F4000, right? That is at this point. So here, this will get replaced by true. So this is true and true, which is again true. This is how recursive procedure works, right? Now we will unfold everything. Here, we know that true and true is true. So true will be returned back to F3000, that is the caller. True and true is again true. Again true will be returned. True and true is again true. So it is clear that this particular function returns 1 when we have all these elements in increasing order. This is important because here we are checking this condition. Is P data less than or equal to P next data? What does it mean? Basically we are checking, is this element less than or equal to this element? And is this element less than or equal to this element? And is this element less than or equal to this element? And so on. Actually, this particular function will return 1 when all these elements are in increasing order. So it is clear that option B is the correct option. That is, for a given linked list P, the function f returns 1 if and only if the elements in the list are sorted in non-decreasing order of data value. That means in increasing order of data value.